Azure Functions, I'll briefly explain what they are, why to choose them, when and when not to use them, why and when I use them, and I'll briefly talk about some extra types like the isolated or the durable. And I'll end the video with a simple setup video to cover a simple scenario. I will make my slides and demo project available on my Patreon. So like the video, subscribe to my channel and join my Patreon. It's a managed service provided by Azure with which you can make serverless endpoints. A bit like, a minimal API endpoint or an MVC API endpoint, but as a managed service and serverless. Does serverless mean that there's no server activity involved? That's not the case. It just means that you only use resources on demand. An Azure function activates on trigger. Such a trigger can be an event occurring. For example, could be an HTTP request, could be a change event on a database or on a blob store. So whenever a file got uploaded or something was modified. But that could also be an Azure Service Bus message coming in that needs processing. Or it can get triggered by a timer. For example, if you need some work to be done every couple of hours. And out of the box, they were intended to do relatively simple tasks with a duration of maximum 5 minutes, but you can extend that to 10 minutes, or if you choose a complete different way of hosting, even 30 minutes. They are stateless by default, but there is also an extension called the durable functions if you do need state. We'll talk more about that later. And they can support many use cases. So the promise is write less code, maintain less infrastructure, and save on costs. Easy to code these things and deploy these things. Very similar as your regular .NET projects, but with a Azure function syntax. Maintaining less infrastructure kind of depends on what you were doing before to run those same tasks. If you were doing a lot yourself, maybe in containerized apps or otherwise, then this might be way easier. But that also points to that it's very easy to seamlessly integrate Azure Functions with other Azure services, managed services like a Cosmos DB, a Azure Service Bus without extra code. Another major benefit is that save on costs because they allocate resources on demand. So whenever the function gets triggered, so let's say that's just once every couple of hours, then you only pay when it's being used. So likely less than 5 minutes at a time. So then you only pay for that small duration. Instead of having a background worker service deployed to an app service that has to be always on just to run once a day. So auto-scalable, that means that Azure will make sure if the load on that endpoint, so that the function gets a decent amount of resources allocated on high load and scales down again on less frequent requests incoming. So when to consider an Azure Functions app with one or more endpoints is when you need to perform server-side tasks. Let's say you just created your front-end only Blazor WebAssembly application and you deployed that as a static web app to Azure for free, because you can host those for free. But suddenly you need to just do a few server-side tasks. It could be storing something in a database or a blob store, or even sending out an email. then you might consider just spinning up an Azure Functions application. You can also use them for processing data or files even, real-time, on schedule, or on event. So on event could be a database change event or a blob store change event. So whenever someone uploaded a file to the blob storage or modified a file to the blob store, then you might want to act on that change and maybe reflect that change in your database. But that could also be the data could also be coming from an IoT device. So let's say every time a device measures the temperature outside and then just pushes that data, but you want to have that data end up in your database, but maybe the data needs to be transformed or something else needs to happen before it ends up in the database, then you can put an Azure Function endpoint in between to perform exactly those tasks. When you need that auto-scaling, so at times you have a high load and at other times you don't need as much resources, then it's a good idea to go for an Azure function, because the alternative would be that you have your own application and you constantly need to scale up or scale down. So I kind of already mentioned it. When you need a bridge, I call it a bridge between Azure services, to connect multiple Azure services. So like I already mentioned, maybe like an Azure service bus receives a message and that needs processing, and that eventually the content of that message need to end up in the Cosmos DB or in a SQL database. Then you could put an Azure Functions app in between to do whatever is needed to read out that message, to process it, to transform it, whatever is needed, and then to store it in the database or blob store. And then lastly, to offload work. That's a bit similar like a background worker service. Some work that takes some time, like processing data or files on a schedule or on an event. When not to use it? Well, I don't think it's your go-to service when you need compute-intensive parallel processing, for example, for AI or machine learning, and tasks that potentially take longer than 5 minutes. Another example would be I have an email sender that sends emails to all my subscribers, but there are certain limits, like I can only send 50 emails per minute. To circumvent that, I kind of have to time out or sleep for over a minute before I start the next batch. If that has to process a couple of batches and time out for 1 minute each time, then I'm quickly going to exceed that 5 minutes execution time. Because after 5 minutes, your Azure Functions app kind of recycles, interrupted and restart. If you pay more, you could extend those 5 minutes to 10 minutes or maybe even 30 minutes, but then you have to take an entirely other approach of hosting it, so more like on an Azure app service, and then you might be paying for a longer duration. I see I made a little typo here that should say when vendor lock-in is an issue. That would mean that you want to be vendor independent, so your app needs to be coded and deployed in a way that is not specific to either Azure, Amazon, Google, or any other vendor. So then you're looking at containerized apps, for example, with the idea that you can change vendors, so just deploy your containerized app elsewhere. I added stateful as another reason, because initially it was intended to just perform simple tasks, relatively simple tasks, and each time a function gets triggered, it performs that task, and the next time it's just recycled and performs that task again. It's not like there's any context data stored in between runs that the second execution can pick up on, so continue on. That's not the initial intention, but if you do need such a scenario, then there's an extension for you which is called the durable functions. We'll talk a bit more about that later, but that's more useful for more complex, more long running and orchestrated scenarios. But I would in most cases probably go for my own background worker service deployed to an Azure app service to perform longer running tasks or more complex tasks. So the major reasons why I would use them is, of course, to trigger an event. So either to act after a webhook executed, for example, the Stripe payment processor. Whenever a payment got processed, then Stripe sends a notification to one of our API endpoints with the status of that payment, and then we'd want to act on that to save something or update something into the database. For that scenario, you might just want to have an Azure Functions app with an endpoint to handle that. In that way, you don't have to expose any of your custom .NET API endpoints. Or like I mentioned before, maybe you just have a front-end application as a static web app and you do need to support payments. Then you could use an Azure Functions app endpoint for that. But I'm also tempted to use it in the future for scheduled tasks where the tasks don't take too long. Most of my scheduled tasks only have to run like once a day, so that could save me a lot of costs, because then I wouldn't have to have those always on. And I think I could probably reduce my Azure costs a lot if I were to transform more of my API endpoints to Azure Functions. However, I'm just going to start with one or a few and see what the cost reduction actually is and how productive it is to work with these functions. And I will definitely use them as some kind of bridge between maybe the Azure Service Bus and a database or a blob store. And I would definitely consider them if I have the scenario where one of my API endpoints has to handle like 80% of the load. Then it might be an idea to just take that one endpoint out and have it as an Azure Functions endpoint, to have it first of auto-scalable and also to not have that load on my custom API. And it might also just make sense to take an endpoint out if it has a completely different responsibility than that of my custom API. So for example, processing files, like offloading work to that endpoint, or just acting on some kind of change event. Maybe that has nothing to do with my API, that has to serve data to my web applications. And then I included a few images from the official Microsoft docs. And in here you see a function processing data to format it in a certain way to then store it into the Cosmos DB. And then you can have a dashboard connected to that Cosmos DB to then, for example, display some kind of analytics or metrics. And that's a interesting use case that I might want to try, because I'm also collecting custom metrics, and it wouldn't hurt to maybe separate that endpoint out and have it store into a Cosmos DB, because that could also be free up until certain usage. So then the API endpoint is free for unless you have like 1 million requests or something. And then Azure Cosmos DB is also free until a certain usage. So that might be very interesting, and also in that manner I might even encapsulate or isolate everything related to metrics, and then maybe easily reuse that as some kind of, well, module for future projects, because that's metrics capturing and saving, processing and displaying is kind of its own thing that you can then maybe easily plug and play into future projects. And then an HTTP endpoint that then triggers a function and then stores it into the database or something else. That's kind of the payment processor webhook scenario that I might have explained. So whenever a payment is processed, Stripe will then post a status to our function, and the function then needs to update the database. And then you have a few extra types or extensions on the Azure Functions app. You could transform it into durable functions. That means that you have some kind of orchestrating function that can call multiple Azure functions and hold some context data in the state. And that enables the functions to use that state, but also have functions run in order. So first function 1, then 2, then 3, then 4. And each function might alter that context data, and then the next function has to act upon that. And then that could also happen on schedule or on an event occurrence, trigger, you name it. And then you have isolated functions, which is also very interesting, because the regular out-of-the-box Azure Functions app would suffice for the payment processor webhook to database use case. But maybe for scheduled tasks, it might get a bit more complex, and you need to, middleware for scheduled, maybe not, but you need to fully leverage the dependency injection and have it run on the latest .NET 8 and configure it how you need it, independent of the host, so where you're going to deploy the Azure Functions app. Then you might want to go for the isolated functions, and these resemble the background worker services. So using and deploying these are actually very similar. So it should be easy to transform from a always on running background worker service to an isolated Azure Functions app. Because the program CS will be very similar, where you can configure everything and the dependency container, and then the actual execution of the functions that then can fully leverage the dependency container and the newest, latest .NET 8 features. And finally, how to build these Azure Function apps is either you can go via the Azure portal, simply find the Function app service and start creating that service. Or you could go through Visual Studio Code, Visual Studio or Visual Studio Code or another IDE once you connect to your Azure environment, so the Azure portal, and have these SDKs installed to fully leverage that. And then you could simply publish your Azure Functions app to a live environment. You can also run them and test them locally. But I'm going to leave all that for the next video. in which I'll explore how to set up a simple functions app to cover that simple webhook scenario. But I want to do that properly with the CI/CD in place, and I'll explore whether I need to convert the functions app into an isolated functions app to access my databases, for example. And I'll go more into depth about which problems I intend to tackle by using an Azure Functions app instead of having my background worker services running non-stop. So if this video brought you any value, make sure to let me know, hit that like button and subscribe, because I'll do follow-up videos on this topic and other topics like Azure Cosmos DB. And I will publish my slides and my produced code to my Patreon, so make sure to become a member at patreon.com/kissstupid. And if you want access to even more of my code, sign up at kisscode.com and get the original code of my best NuGet packages for free. And a limited time offer, my brand website, the one you're currently seeing, with all of its features and all of its codes for you to reuse and build awesome projects with. I hope I see you in the next one.